Greetings. In today's class under embedded microcontrollers, we shall with the 8-bit programming of timer 0. So we know that we have in PIC microcontroller we have many timers. So to start with, we'll just look into timer 0. Timer 0 can work with either in 8-bit mode or else in a 16-bit mode. So with 8-bit mode, this timer can count up to 256 values. That, for example, in case of hexadecimal, it will take the value of FF. Similarly, in case of 16-bit mode, this can work up to FF value or else 65,536 counts. And this has got some registers connected with timer 0 programming. So one register is a timer register low register and timer register high register. These are the registers which will hold the value for a particular delay. So I'll teach you the calculations later. So these registers should be loaded with a value that is needed based on the specification. And another register is a con register, the control register, timer 0 control register, timer 1 control register, so on. These registers will hold some status values. This will have some on and off values, and all these values will be present inside the timer con register. And another register which is associated with timer 0 is intcon register. Intcon register will have an interrupt flag bit which is present inside the intcon. So all these registers are needed. Proper understanding of these registers are needed for the programming of timer 0. So as we know that in case of an 8-bit mode of timer 0, when the values rolls over from FF, which is a maximum value it can count, to 00, this timer interrupt flag would be set to 1. Similarly, in case of a 16-bit mode, these values will be FF, and once up counter as an up counter, this will roll over to 0000. Hence the flag would be set to 1. So this flag is present inside the intcon. Yes. So look into this program. Write a C18 program to toggle. So toggle is nothing but to complement. So if you have given a value of 1, the value should be 0. So you should understand toggling and calling a delay will create a wave. So you will get an output of wave. So suppose a value of at a pin is 0 and you have called a delay. So 0 with some delay, the pin will remain low for a delay time, and then again you toggle the pin, so it will go high. Again it will call the delay, it will remain high for some time. Again you toggle, it will go low, and you call a delay, it remains low for some delay. So if the delay is of equals time, this toggling will create a square wave. If the delay differs, it may be of about 75-25 duty cycle or 25-75 duty cycle. So whatever values you need other than the multiples, so that delays can be caused. So what is the question is, write a C18 program to toggle all bits of port B continuously. Use timer 0, 16-bit mode and no prescaler option to generate the delay. So already we know that we have a tcon. So tcon value can be calculated based on the specification what is given, that is 16-bit mode and no prescaler option as well as timer 0. So the register what was needed is timer 0 control register. So from the program you can see a sub program like delay, timer 0 delay. Under that you can see timer 0 control register, a value is given. So this value is mainly based on the timer 0 control register, where you have configured timer 0 in 16-bit mode with no prescaler. And the problem what is given is with some delay, so any value can be loaded into the high and the low register. And coming to the main program, the B register is configured as 0, so that will be an output port. And inside the main program we have a port B, some values given, and the delay is called. So it will be, suppose if it is with 0 bit, 1 bit, if you study as 1 bit, so that bit will remain 0 and with some delay, and again it will go high and it will remain for some delay. So coming to the delay program, already we have studied as tcon register is configured and any value can be loaded into the high and the low register, and then the timer on bit of the tcon register has to be set 1. then a polling is done whether the timer interrupt flag is set. Until it is 0, it will be remaining in the same loop. So once it becomes 1, it means that the timer has overflow, so the timer can be stopped, as well as the timer interrupt flag has to be cleared. So then only you'll be able to get the next data. And finally, coming to the next program, write a C18 program to toggle only one bit, port bit, fourth pin continuously every 50 millisecond. Use timer 0, 16-bit mode, 1:4 prescaler, and assume crystal is equal to 10 megahertz. So looking into the program, for example, we know that your crystal frequency is 10 megahertz. So f by 4 is 2.5 megahertz, and again you will get around 0.4 microseconds. That is the timer's time without any prescaler. And further it can be divided into 4. So you will get around a value of about 50 milliseconds. Now here you can understand that a value has to be loaded in order to produce this 50 milliseconds. So you should understand that a value like 31250 is should be loaded, so that a 50 millisecond is received. So already we have done a calculation of 0.4 microsecond divided by 4 again further, so you will get around 1 microsecond. Again for 50 millisecond, what is the value that has to be loaded, you will find, and that value has to be subtracted with 65,536, and that can be calculated in the hexadecimal. So from this one can understand 85 should be loaded into the high register, EE should be loaded into the low register, and similarly inside a while of one loop, you can see my bit exclusive or 1. So either we can give 1 and then you call a delay, make a 0 and then you call a delay, either that is correct, or otherwise you can give some other value, or else again an exclusive OR function will also with 1, exclusive ORing with 1 will also causes a complemented value. So here it is the same program again. So we'll load and we'll start the timer, we'll check the interrupt flag, and then once the interrupt flag is set, the on bit will be set to 0, and the interrupt flag is also will be set to for loop. And again we have in another program the same thing. Here also you can go with a factorization, so that if you are going for an 8-bit mode, you can make sure that your number is within 250. Otherwise, if you are going for a 16-bit mode, you can make sure that it's within 65,536. To that program, to that value, a delay program can be written, and to the next factorizing value, a for loop can be written. So that what will happen is number of times. For example, this program what is given above is going to be 20 times of the delay. So you will have it goes on, so that value will be calculated. So 20 into 250 is what is a program that is given. So 20 times it goes with a for loop, and 250 will goes with that of the delay program, and so 20 into 250 you will get the required values. Thank you.